Morning, Brett.
Hey everyone. In this video, I will be going over the ISAT model within the APIM framework for distinguishable dyads. So with a distinguishable dyad, we have a theoretical rationale as well as a measured variable consistent with that theoretical rationale that distinguishes partner one from partner two within the actor-partner interdependence model. And so oftentimes this can be gender, this can be a role that is played, for example, parent and adolescent, or it could be informal caregiver and patient. But we have a way or a methodology for assigning people your partner one and your partner two, and that assignment is not arbitrary. All right. And so even with distinguishable dyads, we can theoretically believe that they are different from one another, that patients and informal caregivers have different levels of depression, for example, or they have different levels of perceived support. And there's probably lots of theoretical rationales on why that might be, but that might not necessarily hold empirically. So the purpose of the ISAT model is to test our theoretical hypotheses that the distinguishing factor that we have implemented is indeed supported by the data, and partners are in fact distinguishable. All right, so I am going to do this the ISAT test within the context of a very basic actor-partner interdependence model. And so I will use 4 variables. This is a data set with only 8 total variables, and I'm using dyad coping for males and females and relationship quality for males and females. All right. And so we will not be using the define command. So I'll actually just delete that. And then in our analysis, I use robust maximum likelihood in most of my analyses. And so I will be using that. Here, it provides a scaling correction factor to address non-normality within our data. And so here in the model command, we are creating the actor-partner interdependence model. And if you are unfamiliar with the basic APIM, there is another video that I have previously posted that outlines the basics of the actor-partner interdependence model, and watching that one before this one may be beneficial. And so what we are doing in the ISAT model is we are constraining the means, the variances, and the covariances of all the variables to be equal. Right? So we are essentially testing whether or not the model data fit is harmed by telling both partners that you're exactly the same on all of the estimated parameters. Again, our means, our variances, and our covariances. Right? And so this provides a statistical test of whether or not couples are distinguishable or not. If this test is not significant, and we'll evaluate that generally through a chi-square difference test, but you may also want to use a delta CFI value of less than 0.01, which comes from measurement and variance literature. There is a 2002 paper by Chung and colleagues that talks about delta CFI. And so if the chi-square difference test is not significant, that means constraining the means, the variances, and the covariances does not harm the model, and it means that they are indistinguishable, which means the empirical data do not support the theoretical rationale. That doesn't necessarily mean that you should abandon the theoretical assignment of some people to be partner one and some people to be partner two. Just know that that the effects that you are finding in the model are not statistically different, which can have significant theoretical implications. So even if this test is not significant, or this test is significant, that's not necessarily a place where you stop your analyses. In fact, that could have a lot of really important findings. And so what we are doing here is we are constraining the actor and the partner effects to be equal. And so you'll notice that I'm using with statements. So this is couple satisfaction, the couple satisfaction index male with dyadic coping male, couple satisfaction index male with dyadic coping female. This is a partner effect right here. And then couple satisfaction with female and dyadic coping with male, that's a partner effect. And then we have the actor effect here with females reports of relationship quality and dyadic coping. And so the reason I'm using with statements here rather than on statements, which is what you would use in the regular actor-partner interdependence model, is because when you use on statements, then you have variance accounted for, which means you are now comparing residual variances. And that is something that's a step ahead of where we are at. Instead, we just want to constrain those covariances to be equal, right? We are also going to constrain the intercepts to equality. So the intercepts will be on our dependent variable, and in Mplus, you will notice that we use brackets to indicate a mean, okay? And so you'll notice here I have A1 for actor one, P1 for partner one, and down here this label is tau one, again, to indicate an intercept. That is, tau and nu are commonly used within the SEM literature to indicate intercepts or means. So I'm using tau one here to indicate, to label this parameter and to constrain it to be equal to the female parameter. So if you have the same label, and again, this you can create whatever label fits you. It's nice if the labels are meaningful, such as tau, actor, and partner. But this could really be, this could be John 1. That doesn't really matter, all right? But it's better if it's meaningful. That way, the results become that much easier to interpret and make sense of, all right? And so then I'm also doing the same thing with our means. And these are on the independent variable. Again, it's just a slight distinction that is kind of a holdover from the full model when you have when we're estimating regression coefficients. So it would be more than fine to just get rid of that line and just consider them all means or intercepts, right? And so we're also going to constrain the residual variances or the variances of equality. Whether or not it's residual is dependent on whether this is a with or a non statement. All right, so here we're going to have with statements, so we're just going to constrain the variances to be equal. But if we want to be accurate and precise, then with residual variances, then we would just simply change all of these with statements to on statements, okay? But we are going to keep it at just regular variances. And I have indicated psi1 and psi2 to constrain the variances of the couple satisfaction index for men and women, or male and female, to be equal. And I've also constrained the dyadic coping for male and female to be equal via these labels, right? This is not the only way to test or constrain the parameters to equality. You can also use, if you're familiar with Mplus, the model test command. We are not going to use that here, but it is certainly possible to do that. And this is where you would actually want to have different parameter estimates here, or different labels, excuse me. And you do psi1 equals psi2, right? That would be another way of testing whether or not these are statistically different than one another. Right, but I tend to use again, the chi-square difference test rather than the model test function. All right, so given all that, we can go ahead and save it since I've made some modifications, and then we can go ahead and run this to see what our model says on whether or not these heterosexual couples that we have are empirically distinguishable. And so you always want to check your basic model information. Number of groups is correct, number of observations is correct. Sometimes if you have missing data on your X variable, Mplus is going to give you an error message or a warning message that says 15 cases were not included. So you would address that by creating a FIML line where you just tell Mplus to just freely estimate the variances and the means of all your observed independent variables. All right. So scroll down. Here is what we get from the SAMPstat request for the output. We just get our means, our covariances, and our correlations. We also get our univariate sample statistics. It's always good to check these just to ensure you don't have any missing data codes that are not properly entered, or perhaps you're using the correct, to ensure you're using the correct variables. Any number of reasons, but I always check my univariate statistics. All right, so now we're going to scroll down to our model fit, which is kind of where we're going to determine whether or not the chi-square difference test of the ISAT model is significant or not. So you have our log likelihood values, then you have your information criteria. These are good measures of model, they're usable measures of model fit when comparing nested models, but they are not good when comparing two separate models that are not nested within one another. So we could use these to conduct a log likelihood ratio test, excuse me, a likelihood ratio difference test to determine whether or not these likelihoods are different than one another. Is another way to test the ISAT model. But again, we're going to use the chi-square since it's the most straightforward and it'll probably be the most familiar to you all, especially for those of you who have done invariance testing within Mplus. And so we have our chi-square difference test right here. And so Mplus offers a diff test option, but we don't need to use that here simply because the omnibus APIM model is saturated, so there is 0 degrees of freedom. And so we know by constraining the means, the variances, and the covariances to be equal, that we know all of the degrees of freedom are coming from those constraints because there was 0 degrees of freedom in the original model. And so you will see here, there's kind of a warning message that you shouldn't use the exact value for the chi-square difference test because we are using MLR, which incorporates a scaling correction factor due to non-normality. That is this statistic right here. So essentially that tells us to what extent our data are non-normal, and then it goes in and provides a correction based on Peter Bentler's work in the early 2000s. And so the most accurate and the most correct would be to use that diff test option or use an online calculator, or you could potentially switch over just to straight up maximum likelihood. I prefer to use just the diff test option, but it is completely up to you on how you test this, knowing that this is going to be somewhat biased. If this is a highly significant p-value. For this to be non-significant, we'd have to be somewhere around 12. So this is 3 or 4 times the value of where we need to be for non-significant. So I feel fairly comfortable saying with a lot of confidence that the model data fit has been harmed due to the chi-square statistic and the partners being distinguishable when we are telling them that they are indistinguishable. Okay. But if you want to be precise, then you should run it with maximum likelihood, and I will actually do that right now so you can perhaps see the difference with the robust maximum likelihood and the maximum likelihood, the differences in that. You can see the chi-square value changed a little bit, not a whole lot. And you can see that that kind of warning message is gone. And then you probably saw that our fit statistics changed a little bit now that we are not addressing any non-normality that we have in our data, right? So here we can absolutely say with confidence that constraining the means, the variances, and the covariances among these heterosexual couples when considering their relationships in dyadic coping and couple relationship quality or relationship satisfaction, it harms the model. And so we have empirical support here for distinguishability. So essentially, we have found empirical data and empirical knowledge that supports our theoretical hypothesis that males and females do differ on these constructs. All right. And so we would, again, tend to use this statistic, but we also may want to take like a gestalt approach and evaluate overall model data fit. Again, as I mentioned earlier, some people recommend using delta CFI of below 0.01. And as you can see here, delta CFI is around what, 0.268. So it's extremely large. And it tells us that it supports the chi-square and tells us that the dyads are in fact distinguishable. All right. And so we can scroll down and look at the standardized and unstandardized effects. Generally, I might peruse these in practice just to see kind of what the combined effects are. And then I would compare that to those to the model where all of those parameters, the means, the variances, and the covariances are freely estimated, just to get a sense of how my model is behaving. But here, these model results aren't all that interesting since the fit is telling us we have to free these anyway. But the only reason I kind of really truly go here, other than just getting a general sense, is to ensure I have coded my syntax correctly. And so if I want this 6.732 with couple relationship quality for males and dyad or dyadic coping for males, that's my actor effect, right? So male on male. And so I want to go find that parameter for females. So couple satisfaction for females, dyadic coping for females, and it's the exact same. So this is a way of double checking my work to ensure that I constrained the correct parameters to be equal in the model. So again, that's the primary reason I check the unstandardized results. So if you scroll down to standardize, they're going to be close, right? But they're going to be a little bit different. All right. So in the unstandardized, that's where everything is constrained exactly to be zero. Your standardized estimates, they are going to fluctuate at least a little bit around the value. You probably won't get a 0.503 and 0.220. That probably is unlikely to happen. And if it does happen, then you probably have some other problems in your data. But if it's 503 and 520, that's not really all that meaningful. But again, I look at the unstandardized results because they're going to be exactly the same. And so that is essentially how you test the ISAT model, and this procedure scales up if you want to test the actor-partner interdependence mediation model, and you add another two variables as an IV, a mediator, or an outcome. You can run this exact same test and just constrain those additional parameters to be equal. Hopefully this video has been helpful in showing you how to code the ISAT model within Mplus to examine whether or not there is distinguishability.